Hello and welcome to today's video and very first episode on a 10-part series where I'll be going through partial differential equations, otherwise more simply referred to as PDEs. So for today we'll be asking the question and answering, what are PDEs? So a partial differential equation involves three main ideas. Firstly, that there are two or more independent variables. Second, there's going to be an unknown function of those independent variables. And lastly, we will have some partial derivatives of that unknown function. Okay, so let's run through a very quick example where we'll be able to see a few of the things that we've just discussed. So let's say we've got some function f of x and y, and that's going to be equal to simply 2xy. The problem asks us to show that this function satisfies the following differential equation. So we have that the second partial derivative of f with respect to x plus the second partial derivative of f with respect to y is going to be equal to 0. So we need to show that this function f satisfies this equation here. So that's our problem for right now. And so this curly d, by the way, that's called del. If you aren't familiar with that, not to be confused with this del, completely different terms. Sometimes it is referred to as partial d, curly d, or even just d by itself. So let's get started. To show that this function satisfies this equation, what we're going to need to do is we're going to need to take some derivatives. So let's take the first derivative of f with respect to x. So what we're going to do now is we're going to look back at our equation, and now we've got 2 times x times y. What we do is we treat everything that isn't an x as a constant. So that means even that y variable here is going to be treated like a constant when we're taking the derivative with respect to x. So df dx is now going to be equal to 2y. Okay, let's see if we can do df dy. And again, now we're going to be treating x as a constant. So now that will become 2x. Okay, fantastic. So let's now find the second partial derivative of f with respect to x. So what we need to do now is we need to look back at the first partial derivative that we had for x, which was 2y. And what we're going to do now is just differentiate that with respect to x. So we see that there's not actually an x in there, and reminder, we treat y as a constant. So when we differentiate a constant, well, that's just going to disappear. And so we see exactly the same thing will happen for when we take the second partial derivative of f with respect to y. That's going to simply be treated as a constant, and therefore it'll be equal to 0. Okay, and so now if we have that the second partial of f with respect to x is equal to 0, the second partial derivative of f with respect to y is also equal to 0, well, clearly we have shown that this function satisfies this equation, since we know that 0 plus 0 does in fact equal 0. Now, this was just a very, very straightforward example, just to show you how we treat these variables when we are taking partial derivatives, okay? You always treat the other independent variables as a constant. And it should be stated that our independent variables are those that are going into that unknown function. So here our independent variables are x and y. And as we will recall from earlier, for our partial differential equations, we know that they must have two or more independent variables. Okay, and that's a very, very quick rundown on partial differential equations, taking partial derivatives, and what some very elementary questions might look like. So one other thing I do want to quickly cover is a little bit of notation. So here I've written the partial derivative of f with respect to x. So just a little bit of notation that this can also be rewritten as f, and then down here, a little x. Okay, and so this little x just represents that we've taken the partial derivative of f with respect to x. So a quick another example. So if I had the second derivative of f with respect to x, what this would look like now is simply f and then sub x. Okay, just a little bit of notation for us to remember. Okay, and so now what I'd like to do is I'd like to give you a question. Suppose that a and b are positive numbers and that we have this function u of x and t, so clearly x and t are our independent variables, And we have that's equal to e to the minus a outside of x minus at plus e to the b outside of x plus bt. What this question is asking us to do now is show that U satisfies the heat equation. So I think I might leave that as a fun little exercise for you to go through that I'll quickly start off next week's video with. So if you have enjoyed today's video, then by all means please leave a like and consider subscribing if you'd like to see more, and follow along for the rest of the series where we'll be covering a lot of different facets and information regarding partial differential equations. If you have any recommendations or any suggestions for what you'd like to see, then please leave a comment down below. I hope you have a great day and stay curious.